So let's take a look at first creating a volume of the fluid for the bottle, and then how we can kind of monitor that volume using a design study. So take a look at this bottle. It is a SOLIDWORKS model. It's been shelled out to the wall thickness we want. But the first thing we really need to do is cap the top off here with some sort of extrusion. I have a more complicated neck area here in this bottle, so I'm just going to go ahead and convert some of the interior edges basically to the depth that I want, where fluid may not exist. So if it's a deeper or shallower depth here, I'm just converting the edges to that depth. And just going to do a simple revolve boss once that's complete. Again, if your bottle or whatever you're trying to do is simpler, you could just be capping it with a simple extrusion. Maybe to this degree of complexity isn't necessary. But if you take a look in section here, you can see that the bottle's been capped, and I did merge the revolve to the bottle, so everything's merged together at this point. Again, if I wanted to go deeper, I could just converted more edges and filled in more of the neck area. Now, once that's complete, we can kind of use my box extrude combine subtract method here, and I'm just going to create another simple sketch on the front plane. It's just a rectangle. The size really is not size doesn't matter here. I am going to add some sketch relations and a couple of dimensions. I would recommend this. Basically, I just want to make sure that this box I'm about to extrude fully encloses the bottle. So if I ever were to change the bottle, height, width, diameter, whatever, I want to make sure the box is always going to be large enough to fully enclose the bottle. So I'll just do a simple mid-plane extrude, maybe about 100 mil in this case, and that'll be sufficient for this bottle. Now here I did not do the practice that we need to do here, so I'm just going to edit the feature. I want to make sure not to merge the box to the bottle, so I'm just going to go back, edit that feature, and I have a body for the bottle and a body for the box. So now we can do the combine, insert features, combine. We'll do a subtract, and I'm going to subtract the bottle from the box. So subtract the bottle body from the box. So when I hit OK, you're going to get this message about bodies to keep, and that's because SOLIDWORKS is actually creating two bodies here, the body of the outside of the bottle area and the inside of the bottle area, which is what we want. So I'll choose just the inner bottle area, and SOLIDWORKS will then get rid of the outer area and leave me with just basically our fluid volume. So we have a solid body for that. We can look at mass properties to measure the volume now. Basically, we have a parametric volume to the bottle size. So here I've set my units to be in cubic centimeters, which kind of corresponds to milliliters. So if I'm looking to be create a 100 milliliter bottle, I basically want to be at 100 here. So I got a little work to do to kind of figure that out, and that's what we're going to do with a design study. A little bonus here would be, some people want to maybe still see the bottle itself. So prior to that, if I roll back in time, what we could have done is a move copy feature here, and basically just copy the bottle body. Just make one copy of it, and you can do it right on top of itself. You could move it off of there if you want. It doesn't matter. That's basically what that message is saying. You're trying to copy a body on top of itself. But I'll say OK, and then when I roll back down, I'll be left with a bottle body now and my internal fluid body. So this is kind of a bonus if you want to try that, so you can still see the bottle itself in the model. Let's go do the design study. I'm basically going to right click on the motion study tab, say new design study. Let's turn off optimization, and we need to add some parameters here. So I'm going to pick just two dimensions. We could pick a number of different dimensions. I'm just going to select this height dimension, and we're going to choose to vary that dimension in the design study. And I'm also going to choose this diameter dimension here, this 44 mil dimension currently. And I'm just giving it a descriptive name here. It doesn't really matter what you name these. I recommend being descriptive. But then in the design study, we can use those two dimensions to do different things. It could be a range of values. Here I'm going to use the range with step option. and just vary the dimensions, in this case the height from 64 to 90, and then add in the diameter and do that maybe from 42 to 62, and we'll just step it by 2 mil for each of those, and you'll see we'll get a number of scenarios that are created automatically, 154 scenarios. So it's going to actually run through 154 different combinations of those dimensions. So let's add a constraint which use sensors in SOLIDWORKS. Here I'll add a volume sensor, and here it's critical. Make sure you pick the internal fluid body volume if you did the move copy operation like I did. But here I can set a range for that volume to monitor, basically to be my constraint, my pass fail. So I'm going to make sure it's between 99 and 101 milliliters basically, and SOLIDWORKS will go and basically run those different combinations of dimensions. We're not going to sit and wait for that, so kind of fast forward ahead here. Again, it only took a couple of minutes really to run 154 scenarios, so I don't want you to think it takes hours. It literally took maybe a minute and a half. But once we do that, we can take a look at the results. All the ones in red are basically ones that don't meet my constraint. I can go and take a look at the ones that do, and as I'm picking on them, you can see the bottle changing in dimension, so I can actually get a visual preview of what this bottle will look like as far as 100 milliliter internal volume. So you can see how using a design study can really quickly allow you to iterate different dimensions and kind of narrow down on a design, especially if you're looking to stay within a certain volume of fluid, in this case for a bottle. So you can kind of get your basic shape out there and then kind of use the design study to narrow down on the actual dimensions needed. So again, I use 2 dimensions. I could have picked 3, 4, 10 dimensions if I wanted. You know, here you can even go and hit the options in the design study and create a report. You can save the results as a CSV. There's lots of things you can do with this information once done. You could also use multiple constraints. So here I just use a single volume sensor. You know, maybe you wanted to do something else as well for a different scenario, such as weight. We could turn on optimization if we wanted, and we could actually then set a goal, such as minimize the volume or mass or whatever. And SOLIDWORKS will basically tell us what it thinks is the optimal dimensions in this scenario. So again, hopefully this is helpful. Enjoy using design scenarios.